Welcome to day 11 of the 12 Days of Christmas series. Today I'll be creating a canon snowball fight game where two players must play against each other. I'm going to get started first by creating a new file called constants and write my window dimensions in here. So window width, window height, and I'm going to set those to 300 and 200. And back in my main file, I'm going to first import Pygame as PG, and then from constants, import all. Then I'll create my Pygame window by first initializing Pygame and then creating a surface for my screen using Pygame display set mode. And I'm going to use my window width and window height constants as arguments. And then I'll use the Pygame scaled flag to upscale the window to the size of my monitor. Then I'm going to name the window using Pygame display set caption, and it's going to be called Snowball Fight. Then I'm going to create an instance of Pygame time clock to track delta time between frames, and then set a variable for an imported system font, Comic Sans, at the size 16 pt. And then in our main function, we want to set a variable called run to true, and this will be our indicator for the activity of the game while loop. So while run, and under the while loop, I want to iterate through Pygame events and check if they press the escape key or the X button on the window. So for ev in Pygame event.get, if event type is Pygame quit, so the X button, then I want to set run to false. Else if the event type is Pygame key down and event key is Pygame escape key, then also set run to false. Now I want to fill the screen the color of snow, so I'm going to say screen.fill and pass the tuple 255, 250, and 250. And the very last thing in the while loop will be flipping the frame buffer. So Pygame display flip. Now if I run the program, you can see here I have a white background at the size 300 by 200. Now because it is two players fighting against each other, I want to have a line down the middle of the screen. So below our screen fill, I'm going to use Pygame's draw line function onto my screen. It'll be the color black, and I want it to go from window width divided by 2 at Y position 0 down to window width divided by 2, Y position window height. So from the top of the screen down to the bottom. And I want it to be thickness by 2 pixels. So if I run the program now, you can see I have a black line down the middle of the screen. Now I'm going to place this while loop activity handler into a different function to shorten the indentation. So in a new function called keep active, I want to have events as a parameter. And the way to separate events from this for loop is by making a variable out of event get. And I can set this events variable into here as well as when calling the function. So this function will return a boolean. So whenever we call it, we want to set run to that. So run equals keep active and pass in my events. Now I can copy and paste into here, delete all of this, and instead of in the function saying run equals false, I just want to return false. Same with the other one. And if everything else fails, return true. So if I run the program, you can see if I press the X window, you can see if I press the X on the window, it still closes. Or if I press escape, it still closes. So let's get started with writing the player. So in a new file called player, I want to import Pygame and create a class for my player. And in my init method, I want to import my player image, which will be a canon. So image equals Pygame image load, and my image is in res, canon PNG, and convert alpha. And it's not the size that I want, so I'm going to scale it down by a factor of 2. So image equals Pygame transform scale. I'm going to transform my past image surface. I'm going to transform it down to half of its current dimensions. So image get width divided by 2, and image get height divided by 2. And this will be self.image. Now I also want to rect. So self.rect equals self.image get rect. And my position attribute will be a Pygame vector 2 at 0, 0. And my player speed will be 20. So if I write a draw method so we can see this in action, have screen as a parameter, and then screen.blitz my image onto my rect, and then back in my main file, I can import player from player. So from my player file, import my player class. Let's make an instance of it real quick. So player variable equals player, and this will be an instance of it. And now to my main loop, I want to say player.draw and pass my screen through it. So if I run this now, you can see my cannon here. Now it's facing the wrong way, but we're going to fix that in a bit. So let's first move the cannon up and down. So I'm going to write another method called move, and it's going to take keys and delta time as a parameter. Before we write the rest of this method, I want to prepare these variables in the main loop. So back in the main file, above my events, I want to make a variable called dt and use our past clock instance dot tick divided by 100. and this will give us the time between frames in centiseconds. And we also want keys, so I'm going to set another variable called keys and use Pygame key get pressed for it. And we could write the player.move now by writing player move, passing my keys and my DT. Now back in my player file, under the move method, we always want to start off with resetting our rect position onto where our self.position is. We always want to assign our rect position with our vector2 position. So self.rect.top left is wherever self.position is. So I'm going to first start off with W and S. So if keys is Pygame key W, then I want self.position.y to subtract by our self.speed multiplied by our delta time. And then if keys is Pygame S key, then I want self.position.y to add our self.speed times delta time. So let's run the program now. And you can see if I press W and S, it moves up and down. Now you can also see that it's going past our screen boundaries. So let's write those boundaries right now. So still in the move method, we want to write if our position Y goes below 0, then we want self.position Y to equal 0. Else if our position Y gets greater than window height minus our self.rect height, then we want to set our Y position to window height minus self.rect height. And we haven't imported the window dimensions yet, and that's why it's underlined red. So let's do that right now. From constants, import all. So now if we run the program, you can see if I run into the window boundaries, it'll stop there. So now let's work on player 2. So in our main file, we want to create a player list of 2 instances. So player list equals a player instance. And let's delete the old line. And back in the main loop, we want to iterate through that list. So for P in player list, I can indent these in and rename player to just P. So if I run the program, you can see it does the exact same thing, only now we can have several instances of it. And in this game, we'll have 2 instances. So to prepare for a second player, we want to go back to the player class and then have a parameter called player type. And we'll set that to self.type. Now we want to take away self from this image variable and create a new self.image. And the reason for that is that we're going to flip horizontally the image depending on which player it is. So I'm going to say Pygame transform flip my image horizontally, so true on the X and false on the Y if my player type is player 1, else just use image normally. And then in terms of position, I want to say position equals 0, 0 if player type equals 1, else I want it to be at window width minus self.rect.width and window height minus self.rect.height, and that will put it at the bottom right corner of our screen. And instead of a set 0, 0 in our vector 2, I want to put my position in there. So back in our main file, we can say player 1 and then player 2. So let's run the program now, and you can see we have 2 players. Only issue is that they both move to W and S. In our move method, we want to separate the W and S and up and down arrows. So if self.type is 1, that's when we want to use W and S. And then elif self.type is 2, then we can copy and paste this here. And instead of W and S, we want to use up arrow and down arrow. So let's run the program now. And you can see W and S is only controlling the left, but up and down arrows controlling the right cannon. So that's it for the player class. Now let's write a Snowball class. So I'm going to create a new file called ball, import Pygame in there, and create a class called Snowball. And in our init method parameters, I want a spawn position and a direction that I'll be going towards. So self.direction will be the direction parameter. My self.position will be a Pygame vector 2 of my spawn position. And my rect will be a Pygame rect at my position at the size of 1010. And my snowball speed will be 15. Now to move the snowball from spawn position to the other side, I want to create a move method that takes in only DT, and if self.direction is 1, then I want my position X to go to the right, because direction 1 will be from my player 1, which means left to right. So plus equals self.speed times delta time. Else if my self.direction equals 2, I want my position X to go to the left. So minus equals self.speed times delta time. Now that that method is done, we can draw it on the screen. So I'm going to create another method called draw onto my screen. And because rect will only draw a rectangle, I want to draw a circle instead. So I'm going to say self.rect equals Pygame draw circle onto our screen, the color white, The center of the circle will be at our position, and I want it to have a radius of 5, so it matches a 10 by 10. Now back in our main file, we want to import the snowball. So from ball, import snowball. And because there are going to be several instances of the snowball at once on the screen, I want to have a list for it. So under our player list, I want to say ball list, make it empty at first, and then I want to write a function that will allow us to spawn a ball. So I'm going to write a function called throw ball, and the parameter will be an event key. And I want to iterate through the player list, and for now I'm going to check if player 1 threw it, and if so, spawn a ball for player 1. So for p in player list, if p type is 1, so player 1, then in my ball list, I want to append an instance of my snowball to the center of my player. So p rect center, and the direction will be the player type. So p.type. So let's call this function in our main loop. So under events, let's iterate through it just one more time. For ev in events, if event.type is Pygame key down, then throw ball and pass in my event key. Now we're not using event key yet, but this will help us with differentiating between player 1 and 2. Now before we run the program, we want to iterate through our ball list and actually draw it. So for ball in my ball list, I want it to move, so pass in delta time, and I want it to draw, so pass in my screen. So let's run the program, and if you see that I press any key, a snowball is spawning, but it's very hard to see because both the ball and the background is white. So above my draw circle, I want to create another circle with a radius of 1 extra pixel. So draw circle onto my screen, and this time the color black, onto my self.position with a radius of 6. And this will create an outline around the snowball. So let's press a key, and now you can see the snowball pretty clearly. So the issue with this is that if we press either WS or any key on the keyboard, a snowball will spawn, and that'll be what we use event key here for. So let's create a dictionary under ball list called player type dictionary, and if our F key is pressed, I want the value to be 1. So player 1 will have F for spawning a snowball, and player 2 will have key return to spawn a snowball. So in our throw ball function, I want to have a variable called num, and then use event key to grab a value from our dictionary. So p type dict get index using my event key. And because num can equals none, if our pressed key isn't F or return, we want to check if that is none. So if num is not none, then spawn a ball. But we also want to spawn it at the player that I've indexed. So and player type equals num, then spawn a ball at the select player type. So now if I run the program, you can see that now I can press W and S without spawning a ball, and only the F key will spawn a snowball for my player 1. But for my player 2, if I press the enter key, the snowballs are going the other way, and only for player 2. Now these snowballs will always be in the list until we remove them. So in our ball iteration, I want to say if ball position X goes below 0, or ball position X goes above window width, then from my ball list, I want to remove that exited ball. So let's quickly print the length of our ball list and run the program. And you can see if I press F, it goes up to 10 and goes back down to 0 once the balls exit the screen. Now let's check for collision. And I'm going to write another function for that called check snowball hit. And I want a ball, I need the player, I need the direction of that ball, and I need the type of player. And this will help me differentiate which ball is owned by which player and if it hit the other only. So I'm going to check if ball.direction is the direction that I want to check for, and if the player type is the player type I want to check for. And if those are the case, if ball rect collide rect with my player rect, so if the ball hits the player, then I want to remove the ball from my ball list. So in our main loop, under player iteration, I want to say for ball in ball list, let's check for a snowball hit with our current ball, our current player, and direction 1, player type 2. The reason I put direction 1, player type 2 is because when ball has a direction of 1, it's going to the right, and I want to check if it hit player 2. Versus a check snowball hit between a ball and player, and direction 2, which means the snowball is going to the left, and if it hits player 1. So let's check for these collisions. If I shoot player 1 snowballs to player 2, you can see they disappear. And if I shoot player 2 snowballs at player 1, they also disappear. Now let's add health to the cannons. So in our player class, I want to have an attribute called self.health and set it to 3. And back in the main file, let's first check if p.health is less than 0, run equals false. And to actually reduce the player's health, we want to go into our collision function, and after a collision, I want to have the inputted player.health and subtract 1 from it. So let's run the game now, and you can see if I shoot player 2 3 times, it'll close the game. Now let's print out which player exactly lost. So if player type equals 1, then I want to print player 2 wins. So if player 1's health goes below 0, then player 2 is 1. And we can check for else if player type is the second player, then we can print player 1 wins. And then after that loss, we can still set run to false. So let's run the program, and I'm going to have player 1 win real quick. And you can see it prints that. Now let's get player 2 to win. Okay, and it says player 2 wins. So now that we have movement, collision, and an endgame result output ready, let's present the current cannon health onto the screen. So I'm going to first create a base health state font render into a variable called current health. And then we'll use font.render to create a surface and create an f string for lives left, and in curly brackets player.list. Let's grab the first one, so player 1, and check the health on that one. Now we want anti-aliasing and the text to be colored black because the background is white. So now at the very bottom, below all of player and ball renders, we can do screen.blit our current health at 0, 0. So let's run this now, and you can see we have lives left 3. Now because our cannon does go below it sometimes, I may want a white background on it. So let's run this now, and there we go. Now it's not covered up by the cannon. Now how do we do the same with the player 2 cannon? So instead of a current health, let's create a health list. Encapsulate this in list brackets, and instead of 0, we'll turn this to an I, and after the font render function, we can say for I in range of 2, because we have 2 players. And back down here, we can say screen.blit health list. Let's do the first one and set that to 0, 0. Let's run this now, and you can see it does the basic same thing. But if we do it for our player 2, screen.blit health list index 1, we can position this at window width minus health list index 1, get width of that surface, and y position 0. It gives player 2 its lives left. So how do we change the health in our health list? So this is an if statement if our health is less than 0, but if our health is greater than 0, then we can simply rewrite this list creation in this else statement, just like that. So let's run the program now, and if I shoot my player 2 cannon, you can see the lives left goes down to 0. So that is it for today's game. Hope you liked it. Some news I want to give is that tomorrow I'll be live streaming the creation of a Krampus inspired story game. Hope you'll be there to see it, and see you soon.